All right, so today we're going to look at solving radical equations. So we've done a lot of work with radicals and simplifying radicals. So now we're going to switch to solving radical equations. Okay, and for the most part, this is going to go the way that you think it would, and they're usually pretty easy except for when they're not. Okay, but then there's also this one extra thing that we need to talk about called an extraneous solution. Okay, so extraneous solution, you'll notice that I put this in a lovely different font to really emphasize the fact that this is a big deal. So what an extraneous solution is it's when you solve an equation and you do everything correctly, but when you get to your final answer, it doesn't actually make the equation true. Okay, that's what an extraneous solution is. So you do all the work, you do everything out correctly, you've done all your steps right. It's not that you made a mistake, right? You did everything correctly, but when you get to your solution, it's still not a solution to the original equation. Okay? So what you need to make sure that you do when you solve these equations is you need to check your answers. Okay? And back like when you were in like middle school in algebra 1, you were solving equations, right? Your teachers would always be like, check your equations, and you would be like, yeah, I know, and you never checked your equations, right? So you need to make sure to check your answers here, not because you're looking for something that you did wrong. That's what you were looking for in middle school. In middle school, you were checking your answers to see if you'd mess something up somewhere. That's not what we're looking for anymore. I'm assuming you're not going to mess up the solving steps. Okay, we're looking for something else, which is what an extraneous solution is. Okay, so you'll see when we get to our first one what is going to happen there. So let's look at this guy here. So what we're going to do when we're solving a radical equation is you want to start by isolating your radical and then just square both sides and follow your normal steps from there. So this one, the radical is already isolated. There's no other numbers on this side of the equation except what's in the radical. So that's isolated. So I'm just going to go ahead and square both sides because squaring and square rooting are inverse operations. So squaring and square rooting cancel. So that leaves me with just 2x minus 3. And 5 squared is 25. I'm going to add 3 to both sides. So 2x equals 28. Divide, x is 14. Okay, so now we have to go back and check our solution. So it's going to be giant square root 2 times 14 minus 3. And we want to know, does that equal 5? Well, 2 times 14 is 28. 28 minus 3 is 25. Is the square root of 25 5? Yeah, so we're good. Okay, so 14 is indeed the solution to this equation. Cool, all right, next guy. So this one right here, the first thing we have to do is isolate the radical. We need it to be so that the only thing on this side of the equation is the radical. So the first thing I'm gonna do is subtract this 3 from both sides to get rid of it. So then I have the square root of x minus 1 equals 9. Now my radical is isolated, so I'll square both sides. So that leaves me with x minus 1 equals 81. So x equals 82. Okay, and then again, we need to check our answer here. So 3 plus the square root of 82 minus 1, we want to know, does that equal 12? Okay, and when you're checking answers, usually you throw a question mark above the equal sign, because we're not saying they do equal, we're questioning if they equal. Okay, so square root of 82 minus 1 is 81. Square root of 81 is 9. And does 3 plus 9 equal 12? Yeah, it does, so we're good. Okay, so 82 is indeed the solution to this equation. You know there's going to be an extraneous solution somewhere, right? The question is just, is it in this one or that one? Who knows? We'll find out. Okay, so this one, we've got our radical isolated, which is awesome. But this one, we have another variable in here, right? And that's going to make this a little bit complicated. You can't subtract the x from both sides and combine like terms because they're not like terms. This one's inside of a radical and that one's not, right? So we're going to do our same steps here where we're going to square both sides. But now I'm going to have to do a double distributive property on this guy. So remember, x plus 1 squared is not just x squared plus 1, right? There's a middle term there. So that's going to work out to x squared plus 2x plus 1. Okay, and if you're not sure how I got that, go ahead and pause for a minute and do a double distributive property. Make sure you're solid on that. And on this side, they cancel. So 7x plus 15. And now we've got a quadratic to solve. So I'm going to subtract everything over onto this side. So it's going to be x squared minus 5x minus 14 equals 0. And then you need to solve this. You can solve by factoring, completing the square, quadratic formula, right? We've got a whole bunch of different methods. Let's see, 2 factors of negative 14 that add to negative 5, negative 7, positive 2. So my 2 solutions would be 7 and negative 2. All right, great. So now we have to check our answers, and we need to make sure we check both of those. So the first one I'm going to check is 7. So if I do 7 plus 1, we want to know, does that equal to the square root of 7 times 7 plus 15? Right? Well, 7 times 7 is 49. 49 plus 15 is 64. And 7 plus 1 is 8. So does the square root of 64 equal 8? Yeah, it does. So we're good. Okay, now I'm going to check negative 2. So negative 2 plus 1, we want to know, does that equal the square root of 7 times negative 2 plus 15? 7 times negative 2 is negative 14, plus 15 would be square root of 1, and that adds to negative 1. So is the square root of 1 negative 1? No. Right? Square roots don't equal negatives. Okay, so this right here is a mark that this is an extraneous solution. Okay, so let's pause and unpack that a little bit. Okay, so square roots, by definition, when you take a square root of something, right, like the square root of 9, the answer to that is 3. Okay, so square root of 9 is going to be 3. So by default, that is always the case. Okay, when we talk about square roots, we always talk about them being positive. But you may be saying to yourself, Miss King, whenever we were doing it, we always made sure that we did positive or negative anytime we took a square root. You're right, but that was a different situation. Okay, when you're just talking about any old regular square root as a number, by default, this is a positive number. Okay, just as a number, not doing anything special with it. We're just saying, oh, the number square root of 9, oh, that's equal to 3. By default, always positive. The difference comes into play when you are saying that you are solving an equation. Okay, so if I'm saying that x squared is equal to 9, when I solve this by square rooting both sides, that's when I need to say that it's positive or negative 3. And the reason why is because we're not just talking about a regular old number. In this case, I just gave you a number and I asked you what the number was, and that's what it is, right? Okay, but in this case, we're trying to backtrack. And as part of our backtracking process, we have to acknowledge that when you take these square roots, it's possible to be either one. Either, right, looking at my original equation, either 3 squared equals 9 or negative 3 squared equals 9. Both of those are true. Okay, so when you take a square root of something as part of the solving process, so as you're solving, right, that's where you need to include plus or minus. Okay, but if it's just a regular old number where you're not solving, then it's always by default going to be positive. Okay, so that is kind of the difference between those two. So when we look at this one, right, we're just talking about, we're not using this as part of a solving process. We're not using a square root to undo a squaring. So when we look at this, it's just saying, is the square root of 1, is this regular old number equal to a negative? No, it's not. Okay, so this guy's extraneous, which means when we talk about our solution, negative 2 is not a solution. My only solution is 7. Okay, and if you were doing this out on a test, I would expect to see you find both solutions, and then show me why one of them is extraneous. Okay, so last one down here. So this guy, this is where I said, you know, sometimes these are a pain in the butt. We have 2 different square roots here. Okay, and that's annoying. We have 2 square roots and a number. So what I'm going to do to make my life a little bit easier is I am going to move one of these square roots to the other side. Okay, so I'm going to set this up so that I have a square root on both sides. Even though I'm going to have this 1, it'll be 1 plus the square root of x, right? It's going to make my life a little bit easier. Okay, so then from here, I'm going to square both sides. So that's going to cancel to just x plus 9. And then on this side, right, do out a double distributive property if you need to, right? You're doing x plus the square root of 1 times x plus the square root of 1. Distribute, combine like terms, right? It's going to work out to 1 plus 2 times the square root of x plus x. Okay, and if you're not sure where I got that, again, go do some side work. And then this is the equation I'm going to solve. So looking at this guy, conveniently, these x's are going to cancel each other out, right? So this guy would cancel with this guy. I can bring the 1 over here, so I'm going to get 8 equals 2 times the square root of x. Divide both sides by 2. And then I can square both sides and get 16 equals x. Okay, so for this particular problem, I actually needed to square both sides twice before I could get to my potential answer, which of course we have to go back and check now, right? So we want to know, does the square root of 16 plus 9 minus the square root of 16, does that equal 1? So 16 plus 9 is 25, so square root of 25 minus the square root of 16, is that 1? Well, square root of 25 is 5, square root of 16 is 4, so yeah, it does. So we're okay, and that's the answer to our equation. Okay, so again, solve your equations, lots of squaring, okay? If you have more than one radical, it's usually easier if you put one on each side of the equal sign. You don't have to, but it's usually easier, I think, okay? Solve it out, make sure you check for extraneous solutions. The places that they're gonna show up, right? Think about what can't happen when you're talking square root equations. I can't have a square root that equals negative, we discussed why. If the -1 had ended up inside of the radical, that would also be extraneous, right? Because you can't take a square root of a negative. So that would also be out. Or if you just got something blatantly untrue. Okay, so like possible things where you could get something messed up, right? If you had something like the square root of 9 equals -3, that'd be a cue that you're extraneous. And we talked about why just a minute ago, right? By default, this is understood to be positive. If you had something like the square root of -9 equals 3, that's also extraneous because you can't take a square root of a negative, right? That would be something imaginary. We've got a problem. Okay, but the other thing that would make it extraneous would be if it's just blatantly untrue. Like if we got the square root of 10 equals 3. That's just not true. So that's another cue that you have an extraneous solution. However, if you did get something like this where it's blatantly untrue, I would go back and double check and just make sure you didn't make a mistake somewhere. These are going to be by far the more common extraneous solutions. Okay, so if you do get something that's untrue, it doesn't necessarily mean you did something wrong, but you might want to go back and double check. Okay, so solving radical equations, again, always make sure that you check to see if you have an extraneous solution.